I think we are changing the picture brightness. Hey! Today we have an Orchid Righteous 3D. I didn't think this card makes it into a video because, well, the card looks quite good and the only thing that was missing was one resistor here on the top. I already added this resistor back and then I tested and, well, look at that. We have a few texture issues. This usually is related to the TMU and memory. So I did reflow all the pins around the TMU chip, also the FBI chip. This is always something that I do usually when I have cards like this. And then I noticed that there is also an issue with this memory chip. And here you can see that the right side of the chip kind of detached from the pad. So the solder cracked. This is easily fixed as well. Some flux and the soldering iron, and then within a few minutes, everything was good. Or so I thought. So the next thing I did is I went into MS-DOS and started Tomb Raider. But still, something wasn't quite right with this card. I'm not sure. I mean, it looks better, but the picture is very bright. I forgot how 3Dfx Tomb Raider looks. I think this is normal. The brightness level of this card doesn't make any sense. So I did a little bit of research and maybe there is a chance that we have a problem with our RAM DAC. I measured many of these SMD components and they all seem to be fine, but there might be a problem with the Vref pin on our RAM DAC. So the RAM DAC is here and there is a pin 46, which is the Vref voltage. And let's have a look what resistance I get. So this side is ground. Let's measure the resistance across this capacitor and we get 75 ohms. So also on this pin then I'll get 75 ohms. Now let's check with a known working Orchid. This is my personal one. So this is my Orchid Righteous 3D. And here across this capacitor we get 83. So two options. Either we have a slightly damaged capacitor here, which means if I remove this, I will get 83 ohms on this pin, or we might have a problem with the RAM DAC itself. Let's hope it's not the RAM DAC. I really don't want to take it off because it's a high chance that I'll ruin the sticker. But let's see what happens when we get rid of this capacitor. It could be that we have partial shorts in there, and that is why we have a lower resistance to ground. 75 still. So it could be that our RAM DAC is damaged, not the capacitor. The card delivers a good picture when I change the gamma to 1.0, but by default these cards run with a gamma of 1.7. And this was a decision made by 3Dfx before they shipped these cards. I think I read somewhere this was due to arcade machines that had CRT monitors and they were quite dark. That's why they put it to 1.7 and this translated to the PC market. Yeah, we have a Voodoo card that just generates a brighter picture. Maybe time to investigate further. And if you want to investigate your own hardware issues or bring a brand new project to life, then I highly recommend checking out PCBWay and their wide variety of services. PCBWay makes high-quality custom manufacturing accessible to everyone. Whether you're fixing up retro hardware or building something entirely new, getting custom circuit boards is incredibly simple. Just upload your design files to their website, use the instant quote tool, and you can get high-quality PCBs at a very reasonable price. They offer custom colors, advanced multi-layer boards, and incredibly fast turnaround times. But they don't just do standard circuit boards. PCBWay is a one-stop shop for engineers and hobbyists alike. They offer a full PCB assembly service, 3D printing, CNC machining, and sheet metal fabrication. You can literally go from a digital design to a finished, enclosed product all in one place. Bring your electronic projects to life today. Visit PCBWay.com and get a discount on your first order. And now, let's get back and try to figure out why this Voodoo card is so bright. So this card just delivers a brighter picture. And I tested also a few things in Windows, for instance 3D Mark 99. This definitely does not look okay. You can go into the control panel and adjust the gamma setting. I will show you this, how this is also done in MS-DOS now. And if I set it to around 1.0 and 1.2, the picture looks okay. So this is what we have already seen. At least we fixed the texture issues. This is one thing, but now we have to figure out why the picture is so bright. So let's change the gamma setting. In Windows, you can just move the sliders. In MS-DOS, you have to set a few environment variables. We have 3 settings: SST, R gamma, G gamma, and B gamma, RGB. And I set it to 1.2. Let's remove the comment of these lines. Well, this looks already a lot better. And now the menu looks good as well. So 1.2 looks like a target value that we should achieve from the RAM DAC. I think this is a good brightness for Tomb Raider. You can let me know in the comments, what do you remember playing Tomb Raider on a 3Dfx Voodoo card? I think this is the correct brightness that we should aim for. I already suspected the Vref pin. Let's maybe measure some voltages. Let's measure what this card delivers versus a known good card. Okay, and we are reading voltages. So let's see what we get on Vref. And we are getting 1.63 volts. This is our bright card, now set to 1.2 gamma. Okay, now the good card is in the system, and you see already, well, maybe it is a little bit brighter than what we had in 1.2 gamma on the other card, but I think this looks more closer to what it should look like. Now let's measure the voltage on pin 46. We get 1.18. So on the other one, we got 1.6. So there's definitely a difference here. Okay, I devised something. This is a potentiometer. So we had 75 kilo ohms. I mentioned ohms before, but this is kilo ohms on this pin 46. So I have here a potentiometer, which I want to put across the capacitor that we have measured before. I added a resistor, and this is just for protection. This is a 10 kilo ohm resistor in line with the yellow wire. I just want to make sure that in case I turn this potentiometer completely in one direction, that it's not 0 ohms and I'm basically shorting the card. Let me add this across this capacitor and see if we can lower the voltage that is on that Vref pin. Because if it is, then this should be a physical knob that allows me to adjust the brightness of the Voodoo card by turning this knob. That would be fun. Let's add it to the card. I've attached both leads. They should be good enough, not touching. 9 kilo ohms, so this is on the low side. And I can go all the way up to 65 kilo ohms. So this is because we are now in parallel to the other resistor that is inside the RAM DAC. This is the highest setting. We're already dropping by 10 kilo ohms. Now let's see what happens when we try this card in the system. And we get 1.5 volts right now. So 1.5, before we got 1.6, I believe, something. We are back at the bright picture, and we still should have 1.5 volts. Yes, 1.55. So let's see what happens when we turn the knob. So here's my potentiometer, 500 kilo ohms. Let's turn it slowly into the other direction. I'm completely on the max setting right now. So let's turn it. And let's see if we can tell a difference in that picture. No. Well, we should have 10 kilo ohm protection, so there shouldn't be an issue. Can you see something? Hey, I think we are changing the picture brightness. Hey! Look at that. Okay, I'm almost, now I'm completely on the other side. Now we are only running 10 kilo ohms across this capacitor. So it's at the very low range of this potentiometer that we are changing now the brightness of the Voodoo card. So what's the correct value actually? Where should we dial it in? Because I want to measure what is across this potentiometer. So this is by default right now. This is how the card is, way too bright. But then when you turn it down, we get to a better level. How would you want to play this game? Maybe like this. Might be the correct setting. What do you think? But now also the big question is, what kind of voltage do we get? Around 1.2 volts. Yeah, I think this is very similar to what we have seen on the working Voodoo. So this is now the value that I want to set on this card. I will take off the potentiometer and measure what resistance we have across it. And then we just have to add a resistor across this capacitor to get exactly to this value. Okay, and what value do we get across the potentiometer? 47 kilo ohms. We need a 473 resistor, so with the markings 473. And I found a suitable donor board with the resistor that we need. There we are. And here's our Voodoo card. And this resistor is just going on top of the capacitor, piggybacking like this. Let me just quickly verify the resistance. And we have 29 kilo ohms. So before we had 75. Well, let's see what picture this card delivers now and what voltage we get. And we get 1.08. So this is very close to the value that we got with a potentiometer. Then let's see how Tomb Raider looks like. Ah, I think this looks good. Menu. Well, that looks so much better, doesn't it? I'm sure nobody could tell that this is a card that was fixed and has a resistor across this capacitor. Now, I'm a bit relieved that it worked, but I'm curious what's your take on this RAM DAC? Do you think it is internally degraded? Is it faulty in general? And I'm quite fascinated that we could fix the RAM DAC with a resistor from outside. Basically modify the voltage on the reference pin by just adding a resistor across this capacitor. And now, well, this Voodoo card seems to be working perfectly. Let me know in the comments if you have a Voodoo card that is also odd with the brightness levels. It kind of feels like the pedestal bit all over again, but we're not going there anymore. This was a Vref issue. That's also interesting. Yeah, if you have more information, what could have gone wrong with this RAM DAC, let me know. Let me know what you think about this fix and what we discovered today. Let me know in the comments. Thank you PCBWay for sponsoring this video and everyone who is supporting Bits and Bolts here on YouTube or over at Patreon. If you want to support the channel, you know what to do. Thank you so much for your time. Thanks for watching, and I hope I will see you again in my future videos. Take care and bye-bye.